And
Hello, how you doing?
not bad. All
All
right.
right.
So test Thursday.
Test Thursday, yes, on.
Okay. Have you been practicing at all?
Not really, no. I've been sick and then I've been like doing some other presentation stuff.
Okay.
Yeah, so I need to lock in.
Yeah, definitely. It's always better to get a good start than a good finish because it feels bad with a bad
Yeah.
start. Uh, these questions here
Uh-huh.
about a diver
Yeah.
are always the same thing. They want to know the start position, so that's
Yeah.
that's when time is zero. They want to know the top position, so that's completing
Uh-huh.
the square. And then they want to know the bottom position. Once you complete the square, you set it to equal 0, and you will find out this bottom and a fictional bottom over here that doesn't exist. They're
Yeah.
always concerned about this, this, and this. And then they will ask you what the domain is, which is limited by when they jump off the board and when they hit the water,
Mm-hmm.
and the range, which is limited by the water to the maximum.
Yes. Okay.
Those are always the questions they want to know. So just get good at all of them. So the first spot when she starts is when time is 0. When
Yeah.
time is 0, we can clearly see that she's 3 meters off the top.
Yeah.
To complete the square, we divide this out and divide that by this to figure out how to complete the square, and then you take the half of that. Well, in short, for the peak, it's complete the square. And for this,
Yes.
it's setting the completed square to equal 0.
Okay.
Is there a question in this grouping that you've at least tried or have trouble with, or in class you were
Honestly,
like, I don't get it?
nothing like in particular. Just
Okay.
like,
These
yeah.
questions are always the same. So I need you to understand what's going on with them. Because he's given you 4 of them, which
Yeah.
means there's going to be a lot of revenue questions.
Yeah.
Okay. When you're doing a revenue question, it always comes down to this. I'm selling something for a price. So I'm
Yeah.
selling something for a price. I'm going to make money, and that's called revenue. Okay?
Yeah.
You'll see the revenue thrown out a lot. That's always the price of the item times the number of items sold, right?
Yeah.
That's the
Yes.
two things. At the end of the question, they'll always want to know this max revenue,
Mm-hmm.
which is completing the square once you figure out how to do the formula.
Yeah.
And they'll want to know how many items were sold, what was the price of the item, and what was the max revenue. Those are the things they will always ask, okay? So,
Yeah.
like all of these things, they come down to graphs that are quadratics. They're going to have a
Mhm.
maximum. That maximum is going to be the max revenue.
Yes.
The X value will determine the number of items sold, but there's a trick. You have to add it to the original price.
Mhm.
These values here will represent when he breaks even money wise. Sometimes they ask that. They say when you make no $0, and that would be
Yeah.
here. So you
Okay.
have to understand what they're asking. But let's look at this question here. We're looking for a price of the item. What's the price of the item?
$10.
Yeah. How many items sold? In this case, it's
400.
essentially right. So the initial price revenue is $10 times 400, 4,000.
Yeah.
The question always, one of them will increase and one of them will decrease. In this
Uh-huh.
question, we see that every dollar that this 10 goes up, increase.
Hmm.
This goes down by 20.
Okay.
How you write that is this. Here's how you construct these formulas always. Revenue is called big R, is going to be open brackets, the initial price plus the change in price times X
Yeah.
times the initial number minus the change times X. So in this case, the initial price was, what's the initial
Uh,
price?
$10.
Right. So we put that in here. The change they tell us is $1.
Uh-huh.
So each dollar it goes up, and be careful, some of them the dollars will go down. In this case, it's going up. The
Yeah.
initial number of items was 400
Mhm.
minus what's the change each time the dollar goes up?
20.
Yeah, so minus 20x. This is always the formula.
Okay.
The initial dollar plus whatever the dollar change is times the
Uh-huh.
initial number of items minus the number of items. Sometimes the items go up and the dollars are going down, but it'll say it in
Yes.
the question. In this question, it says increase in price, decrease in sessions. Once we have a formula like this, when we multiply it, all right, there we go. When we multiply it, we're going to get a quadratic. So
Yeah.
now revenue, remember it's revenue, is going to be equal 4,000, 10 times 400, right?
Mhm.
Minus 200x. You stop me if I lose you. Plus 400x minus 20x squared. Did you see how I came up with all those numbers?
Oh, you just foiled it out,
Yep.
hey?
And then
Yeah.
this middle term will always adjust
Okay.
to plus 200 in this case.
Okay.
There we have a quadratic. We're going to put it in the right order.
That's first. Yeah.
And when you don't see a number in front of the 400, 4,000, it's just a plus.
Yeah.
Notice that you're always going to look to make it simple. You can say, oh, look, I can factor out this minus 20 from all of them.
Yes.
So we're going to do it because it's going to make factoring simple.
Yeah.
We get x squared
200
minus
divided by
minus 10x.
220. Wait, what?
Yeah, so
Oh,
you
divided.
have to divide it all. We're going to leave the 4,000 aside. So we get minus
Minus
10x.
10x.
And we're going to leave the 4,000 out here.
Uh-huh. Yep, and then you divide the 10 by 2.
Yeah, so then we know it's minus 20. Revenue, oh, it's always revenue is equal to minus 20 times x minus 10 squared. There's our completed squared. We now know we have to sell 10 additional items. Oh,
Okay.
sorry, minus 5, half of 10.
Yeah.
Okay, squared. And then we have to subtract the square of negative 5. We have to subtract 25.
Yes.
Then we have to get that outside with the 4,000. So we have to multiply by negative 20.
Yeah, which is negative 500.
Nope, because negative 25 times negative 20 is going to be positive.
I mean, positive 500.
And then we're going to add the 4,000 to that.
Yes.
So we now know the vertex here is 5, comma 4,500. What that tells me is the max profit, because this is R, is 4,500. And it's when we sell 5 additional units.
Yes.
How many units did we sell originally?
400.
No, that's the, oh, sorry. What was the price? Yeah, sorry. The 5 is the price here, or the price adjustment, because see here, it was 10 plus the dollar adjustment.
Okay.
So it's going to be that. So if we sold 5 more dollars, what's the new price? Remember the initial price
15?
was 10. Yeah. That's where you have to go back here and say it's not 5, it's 15. So that means we sold $15 a ticket. How many sessions did we sell? 500 minus 20x. What's our x of the vertex? It's 5. Minus 20 times 5 is minus 100. So how many sessions? 300.
Okay.
So our answer, and what's our max profit? 4,500. That's the y value of the revenue equation. So the problem with this that confuses students is once we're here, it's fine.
Yeah.
Once we're here, it's fine. But once we get into this, they get confused about what this graph is measuring. This this y value has become the revenue. That's why I wrote the R over and over again. This is not the X and the Y of these things anymore. It's the revenue, and the revenue is based on the new price times the new sessions. And the revenue is always going to be this Y value, this graph, because now if I graph this out, The 5 here represents the X values, right? 1, 2, 3, 4, 5. The Y
Yeah.
value is where the R is, and we know the R is revenue. Therefore, the Y is the same as revenue.
Okay.
So that means that 4,500 right here
Mhm.
is the max revenue. 5 extra units, 4,500. This
Okay.
4,500 is not part of this and this, except when they multiply. It's this
Mhm.
that's important for figuring out these things.
Okay.
So it's 10 plus 5 or whatever dollar times X. You just sub it in here. So you would say,
Mhm.
okay, I know 5 is going to achieve my max sales.
Mhm.
5 is going to achieve my max sales. So therefore, my price, I remember I adjusted my price as 10 plus 1x. Therefore,
Mhm.
$10 plus 1 times 5 is $10 plus 5, $15. That's my
Yeah.
new price. The original
Mhm.
sessions was 400 minus 20x. I know that the x value for my vertex is 5. So it
Yeah.
becomes 400 minus 100, 300. And I can confirm this because I can see that if I sell $15 at 300 sessions, I get 4,500, which is my max revenue in the equation.
Okay.
So now that's what all those numbers mean. This 4,500 moved away from being a price or a unit, it became revenue. We had to go back to these original price structures and these original session
Yeah.
structures to figure out the new price and the new number of sessions. Make sense?
Kind of.
Got to practice it then because
Yeah.
they're all the same. You start by constructing the new price from the information here. You start by constructing the new sessions from the information here. And that
Yeah.
becomes, since we already know when I multiply price times units, I get revenue. That's what this is. That's the price. That's the units. I'm just trying to figure out what the best revenue is. And that's always going to be the peak, the vertex of my formula.
Yeah. Okay.
My X values relate to these things, the price and the sessions. The Y value is the revenue.
Yes.
So that's where people get confused. They think, oh, I had to sell 4,500 sessions. But no, that's not
Mhm.
what it is. That's not what it's measuring. This is your
Okay.
maximum number of dollars. So 4,500 is your revenue. You had to multiply your units times your price to get that 4,500.
Okay.
Okay, so you know the original price was this.
Yeah.
So we simply substitute in the X value of our vertex, 5,
Mhm.
to figure out
Mhm.
our new price.
Okay.
Our original units was this. We simply sub in the X value of our vertex to get our new units.
Mhm.
We can confirm we got the right numbers because 300 times 15 is 4,500.
Yes. Okay.
You always have to go back with the information you got about the vertex here and go back to your price and your unit values to
Mhm.
figure out what the new price and the unit. And
Yeah.
beware, it's not always a dollar increase. It could have been $2 increase, which means it would be 10 plus 2x. It could have been $3 increase, 10 plus 3x.
Mhm.
You have to read the questions. Could have been
Okay.
40 fewer sessions, could have been 2 fewer sessions. This will all adjust your values here. But it always comes down to this. If you're going to memorize one thing that it always comes down to, it always comes down to a price adjustment and a unit
Oh,
adjustment. One
price
goes up
adjustment,
and one
unit
goes
adjustment.
down,
Okay. Okay.
which makes sense. If you're going to sell me a chocolate bar for $1,
Yeah.
I might buy it. But if you sell me a chocolate bar for $20, I'm not going to buy it. So
Yeah.
as your price gets too high, you lose customers.
Uh-huh. Yeah.
Believe it or not, this has a real life application,
Mhm.
and it's why they're teaching it to you in finance. They do this all the time with drugs in the States. because there's no regulation on the price. So they would rather sell one pill for $1 million than 10 pill for $1,000.
Hmm.
So let's see if you can tell me how to construct this.
Okay.
It's the same thing. One of the things is going to go up. One of the things is going to go down.
So
You have to start with the initial price to figure out what the initial price was. Because sometimes they'll ask what was the initial profit.
the initial price is $8,
Okay.
and then there's 2,000 visitors.
So if I was to figure out the revenue, what would you do?
Uh, add them?
No. So if I
What?
sell 10 chocolate bars at
Yeah.
$5, I'm not adding 10 to 5.
Times in it?
Yeah, I have to. If I sell 10 chocolate bars at $5, I multiply it by 10,
Yeah.
and I get 50. So how much did they make originally?
1,000.
Yeah,
What? Oh.
that's okay. I don't get the calculations. I don't care about. I just want you to understand how to do it. Okay,
Yeah.
since we know revenue is price times units, and you
Yeah.
know the original price was $8, what does the question say happens? Oh, I'll just move it over a bit. Just a second.
Um.
There we go.
So 100. So for $1 increase, you lose 100 people.
So that means if my initial price is $8, what do I do to it?
You $1.
I got to add 1x.
1x.
What do I do with the initial units?
Um, 2,000 minus 100x.
Yep, that's right. So there's your quadratic.
Yeah.
But remember that the y value here is measuring revenue. So if we FOIL it,
Mhm.
I'm going to do the math for you, okay? We FOIL it.
Yeah.
X squared, right? The middle terms always adjust. Minus 800x plus 2000x. You'll want to rearrange it in the right order. So revenue is equal to that plus 1200x
40
plus 16,000. Okay, what's next? It always comes down to completing the square.
Complete the square and pull out the.
Okay, do it for me.
So you pull out the negative 100. So 1 2, divided by 100. 12. So it's, yeah, x squared plus 12, no, minus 12.
Mm-hmm.
Okay, and then you do half of 12, which is -6.
Mm-hmm.
Yeah, and then you do 36
Plus or minus.
minus,
Mm-hmm.
and then you times that by negative 100.
Mm-hmm.
So, which is 3,600.
Positive or
And
negative?
then positive.
Yeah.
And you add, yeah, yeah,
Okay.
160.
Okay. What's my x? What's my vertex?
Oh, it is +6 and
What does the
19,600.
19,600 mean?
That is the
So what was R here,
revenue.
right? And is R is on the Y side. Normally we'd see a Y there, right?
Yes.
So that's the Y value there, right? Because this is always X
Uh-huh.
comma Y.
Oh yeah, XY, yeah.
So that
Okay.
means if that's Y and Y is revenue, that's
That's the new revenue.
the
Like, so,
maximum revenue because you found the maximum point on the vertex.
oh,
So that's the max they can make.
Hmm.
How did they make it? They made it by selling how many X values?
8, 6.
6. What was your
Yeah.
original formula? Right here, right?
Yeah.
This one represented units.
Mhm.
This one represented price. Your X is 6. What's your new units? What's your new price?
Wait, say that again. What?
This is the formula for your new price. This is
Uh-huh.
the formula for your new units sold.
Yeah.
You can see that from your graph, you figured out the units that achieve the max revenue. Six
Yes.
makes you 19,600. That's the
Uh-huh.
maximum. So my
Yeah.
question to you is, what's the new price and what's the new unit sold? Okay, what does the
You
six mean? What
just
does the six mean in the vertex?
what? Like that's like the X value?
Yeah, that's right. But what does the x value mean in this formula up here? What does this x value mean, and what does this x value mean here?
Um, like what? Like not no number?
Yeah, so for each additional x value, I adjust the price by $1. And for
Mm-hmm.
each additional x value, I lower the unit number by 100. What's the x
Yeah.
value you found in the
Yeah.
vertex?
Um, 6.
So probably it should go in where you see x.
Yeah. For both. Yeah. Okay. And then
So what happens here?
um, it's 14.
Yeah, what happens here?
Um, 100 times 6. It is negative 1,400.
Nope, that's a positive 2,000. Where do I put the 6 for
Oh,
x?
in the X spot. So it's
So negative 100 times 6 is?
600.
So it's 2,000 minus 600. It won't be negative.
Oh, 1,400.
Yeah. So that means I sold how many units at what price?
1,400 units at $14.
In terms of this question, it means I had 1,400 visitors and they each paid $14. That's the maximum I could make.
Okay.
The price that people would accept was $14. Even though I got less visitors than 2,000, I made more money. It's actually
Okay.
beneficial for me because fewer people came into the park. That's the kind of
Yeah.
thing the question is going to ask you. So
All
this
right.
revenue section here is the units right here. This is where we would put this.
Okay.
But it's important you understand what each of these numbers are because when I asked you, you couldn't tell me.
Yeah.
And you're only going to get
Okay.
that way by practicing. And I don't think you've practiced one of these. So if you look, how do I know I got the right numbers here? 14 and 1,400 units. Take your calculator and take $14 and multiply it by 1,400 and tell me what you get.
14 times. I get 19,600.
And look at what our value for the Y value was for the vertex.
19,600.
Right. So this tells you what the max revenue was, and the X value that we sub into here and here tells you the number of people who came and the price of the new price of the ticket.
Okay.
Because the price of the ticket went up by 8 plus 1 times X, we have to use this X here
Mhm.
from the vertex back here and here to answer the questions: how many visitors, what's the new price, and what's the max revenue.
Okay.
Those are the 3 questions they always ask. What's the new
Yes.
price? What's the number of visitors? What's the max revenue?
Right.
Always. Tell me how to read this question for me. Hang on.
Middle club so sweatshirts as a fundraiser. They sell thousands of insurance a year at $20 each. They're planning to increase the price. A survey indicates that for every $2 increase in price, there will be a drop of 60 cents a year. What should the say? Okay, so the price, um, they sell $20. No, the price of the shirts is $20,
Hmm.
and they sell 1,200.
Right. So that's, I'm just going to cut to the chase for you. They make $24,000 at that price and selling
Yeah.
that many tickets, but they suspect they can do better.
Uh-huh.
So what do I do?
They
What do I do to the price? So it's always
so
price times units. What do I do to the price? How much did the price go up?
um $2 increase
Okay, so what would I put here?
2.
The answer is no.
No.
No. So what did I always tell you? You start with what's the initial price
So 20, and then you
plus
do
the change times X. 20 is the initial price. How much do they
20.
increase it by?
Um, I would increase what?
In the,
$2?
yeah, 2X. So this is always how you adjust your price. Initial
Yeah.
price plus the change times X. Okay, what about units? What's how it's the units are similar.
1,200
Mm-hmm.
plus minus 60x.
Yep. If I
Okay.
expand that, I'm going to get a quadratic, right?
Yes.
Okay. Here's the quadratic I'm going to end up with. Revenue is equal to negative 120x squared minus, let's see, 10, 1200. Okay, plus 1200x
Mhm.
plus 2400. So that's the new quadratic. It's clearly, they're all facing downwards. That's the key to this. They all have maximums. They all have maximums. When you find the vertex, you're finding the max X and the max Y. The Y is going to refer to the max revenue. The X is going to refer to the units changed.
Okay.
Okay, so complete the square for me.
All right. So you want to pull out 120 from 1,200.
Sure.
So,
Yeah. Negative 120, not positive.
yeah.
Yeah. Okay.
10, negative 10.
Yep.
X. Okay. And then half of 10, negative 5.
Yeah. So suddenly that we get rid of this x squared and we just put negative 5 and we put the x squared out here.
And then you do 25.
Minus, always minus 25.
Yeah. Times minus 20.
Yeah.
120. Sorry.
Yeah.
120. 2,425.
No, close.
What?
Yeah. So 20 times 120 would be 2,400. 5 times 120 would be 600. So the total would be 3,000
Okay.
because it's minus 25 times minus 120.
Yeah.
Mhm.
Okay.
Okay, what's the total there? We got rid of that now.
27,000.
Yeah. So what's my X and what's my Y, my vertex?
Sorry, give me 1 second.
Yeah.
Someone's giving me a call here.
Yeah.
Sorry. Hello? Yeah, what's up?
50 times?
I'm kind of in the middle. Sorry about that.
That's okay. So what's my X and my Y and my vertex?
So the vertex is positive 5, 27,000.
Yeah. What does this tell you?
the revenue is 27,000.
Yeah, that's the maximum revenue because it's the maximum at the
revenue.
time. Yeah.
And then you can find what the new price and the new,
Yeah. How do I do it?
so you substitute the 5 in
Yeah.
for into like the original thingy.
Yeah.
So 10, 30, 30, and
So your teacher's going to want to see this, by the way.
okay.
Okay.
Yeah.
And units.
And then for units it is see times 900. So it is you substitute it in.
Where?
And then,
What do I
for
write?
the
Just tell
X
me
you
what to write.
put 1,200 minus 60. Okay, and
Okay.
those 1,000, yep. And then yeah. And that equals 900.
Okay. So how do I know? So according to this, I can sell 30 units at 900 to get my max revenue. How do I know I calculated these two numbers right? This one and this
If
one.
you add them up and they equal the original.
Nope. So that's the new price and the new units. And when I always find out revenue. What do I do with price and units to find revenue? Yeah. So if I were to multiply those two numbers, what would I get?
27,000.
Right. So I just proven to myself that I
Yeah.
converted the correct numbers because I know that the max on my graph here is 27,000. And when I
Yeah.
multiply these two numbers, I also got 27,000. So these two numbers are the correct numbers. It's a way of verifying that I calculated the new price and the new units correctly. Okay, so those are the key questions. What's the max revenue? What's the new price? What's the number of units sold? And they might ask, what's the vertex? 5, 27,000. Those are the same if they're going to ask it over and over again. Sometimes it goes up, sometimes it goes down. What does this one look like? What does this one look like? Think back to the first question we did.
Like when you just complete the square.
Yeah, and what does it
And
look like? It looks a lot like the diver question, right?
yeah, you just
Diving up and then hitting the water. Just they're using a different scenario. Here, Hercules throwing a rock. It's the same thing. It's a diver going up. What's the three values they're going to want? This value, and this value.
there. Yeah,
Okay, so this value is the easiest one to determine. How come?
because that is 80.
That's when, yeah, that's right. That's when time is 0. So you can ignore that. He's at 80 meters up. They kind of
Yes.
told us in this question, but you could answer it. So let's complete that square. How do I complete it?
Put up 5.
Notice it's the same thing over and over again, but the
Yeah.
secret is practice.
-6.
Yep.
36 times -36
Oh, hang on. You skipped a step.
times
It's t squared negative 6t. You skipped you skipped one step.
what? Oh, what?
So you factored this out, the -5. That's fine. You got -6 plus 80.
Okay, and then half of
That's
6,
right. Don't forget the half. You got to take the half of 6 before you factor it out.
3
So it's kind of it's a big difference. T
9
minus 3 squared now.
-9
Subtract 9. Yeah.
45
Plus 45. Right.
is 125.
There you go. So what's the vertex?
Positive 3, 125.
What does that tell you? If x in this case is what? Look up here. What is x in this equation up here? It's not x now. It's what? Why do they put something else there?
AX to B, okay, and BX to C.
What letter do you see there?
It's T.
Yeah, and t they tell you represents what here?
Seconds.
Time in seconds. Yeah, sometimes it'll be minutes, sometimes it'll be something else. So that means our x-axis is actually in time in seconds. What does this part mean? What's that h mean?
Height.
Yeah, that means
Height.
our y-axis is going to be
Time.
height in meters.
Okay.
So what does this vertex of 3 comma 125 tell you? If x is in seconds, if x is in seconds,
X is the time and Y is the height.
right? So
Yeah.
in words, what can you tell me about his rock throw? How high did his rock would reach?
125 what seconds?
Yeah, you have to go. No, height is never in the seconds.
125 meters in
And
8
how long did he?
seconds.
How long did he throw it before it reached that height?
3 seconds.
Right. Okay. Great. Now
Yeah.
here's the last tricky part. It's always that question. They're always going to want to know that question. What time did it reach the maximum height? What's the maximum height? Down here, what's the height when it hits the water? What's the height when it hits the water? If this is 80, where he's standing, and this is 125,
0.
zero. That's right. Now
Yeah.
you've completed the square, haven't you?
I have.
Okay. We know that this is the formula. Height is equal to this, or
Yeah.
the thing you just completed is also true.
Yeah.
You just told me when it hits the water, height, which is here, right,
Yeah.
is 0.
Okay.
When does that happen? Solve for t.
So, what you want to do is minus 125
Yep.
both sides. Uh, Divide by
By 5 or
-5.
right. So we get
So
2 and 25.
you want to square root them.
Right.
5, yeah.
What's a little problem I didn't do? I've only done half the correct answer. What else do I have to do?
Because there's no plus or minus.
Yeah, so I have to also do this equation
Yeah.
with a -5.
Uh,
Okay, solve this one. T minus 3 is equal to 5. What do I do?
+2.
Plus 2?
I mean 3.
Yeah. So
Yeah.
what's 5 plus 3?
8.
Right, so time when it hits the water is possibly 8.
Yep.
Okay. And then over here,
Oh, positive. So, -2.
-2. Okay.
Yeah.
Looking at the drawing, the 8 makes sense, right? It's over here. It hits the bottom at 8 seconds. Here's where he starts his question at 0 seconds. What's the -2?
Yeah.
What's the -2 mean?
Seconds. Then those ones. Yeah. So that's like what? Like the height or the?
No, the height's always 0 when it hits the water. -2 is the x value, which is time.
The other x value,
Yeah, but
That's
why is that not relevant?
because you can't
Can't go back in
Good.
time.
you can't go backwards in time. Yes.
Yeah, we're only measuring from 0 seconds to when it hits the water. When does it hit the water?
8 seconds.
So that's the domain.
Oh,
Okay. And we're only measuring from the height of the water, which is 0, to the vertex maximum. What was the vertex maximum?
1.5.
Right. So that's the range.
Okay.
So in these questions, domain is limited and range is limited
All right.
to real life. We don't care about the rock under the water, and we don't care about negative time. The domain is the x value, it's time. The range is the height, the y values.
Okay.
So range is always the y values, or the y-axis. In this case, it's height. And domain is always the x values. In this case, it's time in seconds. So we
Yes.
only care about the time that the rock is in flight till it hits the water.
Uh-huh.
which is 0 to 8 seconds. And we only care about the height from when it hits the water, 0 to max. So that's the range. Can you ask your teacher before the test comes if he wants the range expressed like this? Typically, they want it like this. They want the range expressed like either like this.
先选 D 哈，待会有事。
Mm-hmm.
That's one way they might want the domain and range.
Yeah.
Or sometimes your teacher might want it like
不
this,
是的话，那我也可以背吧。
which is a way of skipping the X and the Y. Just saying,
Yeah,
it's just
okay.
saying the minimum is 0, the max is 125, the minimum is 0, the max is 8. It's just skipping this part.
You're right.
Ask your teacher which he wants because it'll matter for points.
16点34
And you need to practice some of this sometime. Like the problem with this is when you wait, the stress increases
Yeah.
and you
Mhm.
don't want stress.
Yeah.
So in future on the weekends, you got to have to find time to practice.
Yeah, I will. Yeah.
Okay.
Yes. Yeah.
All right. Let's have a look. So again, he wants to know the max height, 125. How long does it take the rock to reach max height? 3 seconds. How long is the rock airborne before it hits the water? 8 seconds. When the
Yeah.
rock hits the water, the height is 0 meters. And
Okay.
then it says here, how long in seconds is the rock at least 100? Here's a good question. This is important. When is the rock 115 meters above the ground? Okay. This is a tricky question, and I should have covered it. This is also a common question they throw in. So we're going to keep our formula right here,
Yes.
our first formula. And we're going to keep in mind that the max height that we've determined is 125, right? From that formula.
Okay.
Okay.
Uh-huh.
Height based on time. But this is an interesting question. We know Hercules is standing there and he throws the rock, and that's when it hits 3 seconds to a
Yeah.
maximum of 125. Then we know it goes down and hits the water at 8 seconds, comma 0. Good?
Yeah.
Notice 125. They want to know when the height is 115. So notice that the
Mhm.
height is 115 below 125, right?
Yeah.
So they want to know at this point.
OK，
But notice that there's 2 points when it hits 115. There. So
Yes,
there's going to
okay.
be 2 times when it hits 115. This is a
Okay.
height, isn't it? 115
Yes.
meters. Where do you see height? X here or Y there? Where's height?
Okay.
Where's height in our equation? Here, T, or here, there?
Here, there, the H.
That's the Y. Yeah, that's Y. So when they
Yeah.
ask a specific height, here's what we do.
Mhm.
And then we put in the rest of our question. Just like we solved for T when it was 0, we're solving for a fictional height of 115. Guess what? There's going to be 2 answers that are legitimate because it reached that height on the way up and it reached that height on the way down.
Yeah.
Solve for me. How do I solve it?
So
It's the same when we
What?
solve for 0. We're trying to figure out what the T is.
okay, so you minus 125.
Yep. 115 minus 125 is minus 10.
Okay.
So we get that.
Then you will want to divide -5.
Yep. Minus 10 divided by -5 is 2.
Yeah. Okay, and then you square root.
Yeah. So we have to do 2 things though. What do I have to do?
是没有懂面的。
Plus or minus.
One is positive.
One is
The
minus.
other has a minus outside. So with the positive one is going to be equal to T minus 3. And the negative one is going to be equal to T minus 3. Be aware that there's 2 legitimate answers. So what about this one? What do I do next?
Mm.
So So it's just pretend that says 2 instead of square root of 2. It's still just a number.
Oh,
How do I solve for
just
3? T rather.
plus 3.
Yeah. So in this case, it's going to reach the time at square root. It's going to
Yeah.
reach a height of 115 at square root of 2 plus 3. We'll get to what that means in a second. What about this one? Negative square root of 3. Negative square root of 2.
You minus it though.
No, here's
It's
t over here. How do I get rid of the, like I'm trying to solve for
minus
t.
3.
Why would I minus 3 if it's already minus 3?
Oh, sorry, plus 3.
Right, so in this case, it's similar to this one here, except in this case, the square root has a negative sign in front of it.
Yeah.
Okay, and they're both in seconds. What I've written here is called an exact answer. It's called exact because square root 2 is nice and clean. If I take square root 2 in my calculator, I get a nasty, messy, long number.
Yeah.
So sometimes your teacher will want this as well, but I'm just letting you know the accurate answer is negative 3 plus square root of 2 seconds and 3 minus square root of 2 seconds. You're allowed to rearrange them. 3 minus square root of 2 seconds is a legitimate, accurate answer. And 3 plus square root of 2 is a legitimate, accurate answer. Seconds. And you'd always put the units. Don't lose marks.
Yeah.
Always put the units. Seconds. If I do the calculator, and this one I add 3, this is my first answer.
Yeah.
And this is my second answer. I just make the square. What I do is I do 3 and I subtract 2 square root and hit equals. So here's my second answer. Seconds. Here's my 2 answers. What do they mean? Go back to the drawing.
Those are the x-intercepts, so
Not x-intercepts. What did we start? What was the height we started with?
115.
Yeah, that's not an x-intercept. That's 0 would be x-intercept. This is the time when the rock hits 115.
Yeah.
So here's the x-intercepts down here. This is what we figured out up here.
Yeah.
What does one, can you tell me where one occurs and where the other occurs in this drawing?
The farther one.
Yeah, so this happens later, so it's on the way down.
Yeah.
And this happens initially, so it's after he throws it up.
Huh.
And this is a common question. What is time does the rock reach this height? You'll get it in Ferris wheel questions too. What time does the person reach this height on the Ferris wheel? There's always 2 answers. One on the way up, one on the way down.
All right.
Okay. Notice that he says in seconds. Ask your teacher if he wants exact answers or a just answer. Notice this is another revenue question. It's the same thing, only this time the bushels, the units are going up and the dollars are going down. The trick in this question is we have 20 cents, but $4. We either have to convert the dollars to cents or the cents to dollars. You can't put things in an equation that aren't the same units. We'll get to that one. That's a common one too. Let's get to Flora Farmer. We'll skip that one, the revenue question, because we've done enough revenue questions. Read this one for me. I'll just put it over, and once I stop screwing up the copy and paste. There we go. Okay, read that for me.
I'm clarifying any disclosure. Apes. Way 3 sections.
I guess he showed a picture actually, so let's look at the picture. So he's using a fence like this in this picture. Okay, so I'm going to grab the picture. And I'm going to just get rid of the pig images. It actually would have helped if he skipped the pig images. Okay. So inside he made a fence like this.
Yeah.
And a fence like this.
Okay.
And a fence like this. And even though it's not doesn't look like the same size, they're supposed to be equal size. He used 1,800 meters. That means he started with 1,800 meters and he laid some there, he laid some there, he laid some there, he laid some there. He laid some there, he laid some there, he laid some there. He laid some there, he laid some there, he laid some there. See, he laid some there. So he used a
Yeah.
little extra fence here and here. Right?
Yeah. Mhm.
Okay, if this whole thing was called, let's call this whole length here X.
Mhm.
So these are the same size, right? This one and this one.
Yeah.
So there's two of them. And this is called Y.
Yeah.
Where else would I put Y?
Nowhere, hey? What? Oh
Well,
no, on the other side of
there's this
the
length
other,
here. There's
just that
another
one.
there's another
Yeah.
Y there.
Why?
And there's another
Why?
Y there. So that's the trick
Yeah.
of this question.
Yeah.
If I was going to
Wait,
add up, if I was going to add it all up, let's say this was 50 up here.
Hold up. Oh, can I just 1 second? Some guy just came into my room.
Yeah.
Sorry about that. Some dude just came in my room and he was just like, I don't even know what his problem was.
Okay. So if I was going to figure out the area of this formula of this rectangle over here,
Yeah.
what would the area of this thing be?
Um,
What would I
it
multiply?
would be the X times Y.
Right, right. So let's mark that down. Area is equal to X times Y.
Yeah.
Okay. If I was going to mark down how much fence I used, in other words, not area, how would I measure that from the drawing over here that we did?
Mhm.
How would I
Yeah.
how would I measure that? If that's length Y, and that's length Y, and that's length Y, and that's length Y, and that's length X, and that's length X, how would I measure it?
What? What do you mean? Like,
Okay, so if I used 500 meters here in X, it means I
Yeah.
would have used 500 over here as well. And if I used 150 here for Y,
Yeah.
and 150 here for Y, and 150 here for Y, and 150 here for Y, how would I figure out what the total is? So fence is like I'm laying it down like this. There's my 150 in fence. There's 150 in fence. How would I figure out what the total is?
like you just times or add them up, hey? Or what?
Okay. So if
You
I
just do
were
that. No.
now you have to give me one answer, not both answers.
So what I would do is,
So they're each 150 for Y.
yeah. So just do what? 500 times 150.
Okay, but that's an area though. I'm not asking for the area. I'm asking how much fence I laid down here. Let's start here. How much fence did I lay down here?
Oh, 500.
Okay, and then I did it again over here for 500. What's the total fence?
Yeah, 1,000.
Ah, thank you. And then I did it 150. What am I up to now?
1,150.
And then I did another 150 here. What am I up to now?
1,000 to 300.
Yep, and another 150 here. What am I up to?
1,450.
Yeah, and another final 150 here. What am I up to?
1,800.
What did you do?
You added each
Right. Now I'm not going to use the
side.
now I'm not going to use the numbers.
Yeah.
Tell me how I would add up the perimeter.
What? Like you just add up each side, hey?
Okay. What would that look like?
500 times
No, we're not using numbers. How did you add it up? Yeah.
X plus Y plus X plus Y.
Well, you're missing a whole bunch of Y's. You just added 154
Oh,
times and now
oh.
you're cheating.
Yeah.
Try again.
X plus Y plus Y plus Y plus
Yeah.
Y plus X.
Yeah. Is there an easier way I can
Yeah.
group these things? Don't I have similar things here and here? How many X's do I have?
2,
Okay. How many Y's do I have?
3.
Okay. Would you agree?
Yeah,
Does the question tell me how much fence I have to use for the perimeter?
it does.
Okay. How much?
1,800.
Right. So I'm going to replace the word perimeter with 1,800. Whenever you have two equations, we now have two equations. What's this question concerned about? What's the major final question? What do they ask at the end of it? They always ask at the end.
Oh, what is the overall dimensions of the pig pen?
So these are dimensions, yeah.
Yeah. Huh?
If
Oh yeah, if you want to have the max. area.
maximum area, what have we been working with over and over again?
Maximum.
For a vertex for a parabola, right?
Yeah.
So we're probably going to have to come up with some sort of parabola formula. The problem is
Mhm.
all our parabola formulas for max area, whatever, do not have an X and a Y. So
Yeah.
whenever there's two formulas, you have
Yeah.
to find a way of replacing one of the items in there
Oh,
with the other item.
okay.
So since we know we want to find max area, we're going to be working with this formula because this is the area formula.
Yeah.
And they want max area, so we got to work with this one. I want to find
Yeah.
a way of replacing that X and that Y. And so I'm going to rewrite this perimeter formula in terms of either Y is equal to or X is equal to.
Yeah.
So let's start with saying if I wanted Y all alone in this formula here, how would I get Y all alone?
You. What you?
How did we get
Different.
T all alone in the time questions? Did we do? Remember the last question? What were we doing? We're always subtracting and dividing things that were harassing our letter, right?
Yeah.
So there's a big thing
Mhm.
harassing our letter, but it's a big group of thing.
So you just what? Divide 2x.
No, because it's not being multiplied by 2x. It's being
Yeah.
added to 2x.
Mm-hmm.
So how do I get rid of something that's being added to it?
Mm-hmm.
What's the opposite of addition?
Subtraction.
Yeah, so how do I get rid of 2x?
You subtract 2x.
Yeah, invisibly, there's a big old positive here in front of 2x, which means 3y is
Yeah.
being added to it. If there was a negative here, you'd have to add 2x, but there's not. There's nothing there, so there's a big old positive there, which means I have to subtract 2x to get rid of it. 2x minus 2x plus 3y If I do that, I have to do it on the other side too. Okay? Good? Aiden, you still there?
Yeah. Do you hear me?
Barely. So this disappears, right?
Mm-hmm.
I don't think I don't know what you're doing. Okay, so new rule, Aiden. From now on, the video has to come on. You have to turn the video on. Next session, the video comes on. I can't have it off because I don't know what you're doing. And I need to know you're paying attention, and I need to know you practice these. So in the next session, you have to do some practice beforehand.
Yeah, I will. Okay.
Okay. So now how do I get 3y all alone? It's being harassed by one last thing.
You divide.
Yeah, by 3. So I divide it by 3. I can divide it by 3, and I can divide it by 3. So
Yeah.
I'm left with this. 1800 divided by 3 is 600, which is fine. But notice I'm left with something annoying here. I'm left with minus 2/3 x. So I have a fraction. Fractions are annoying. Now that we've practiced isolating y,
Yeah.
and we're left with an annoying fraction, I'd like you to do the same thing, but isolate x. So how do I get x all along?
You minus 2.
Oh, by the way, it's not, I got that wrong. It's not 3y's, it's 4y's. So actually, let's go back there. And instead of dividing it by 3 over here, we're going to divide it by 4. And we actually get a nice one. So we get 1809, we get 450 minus, but we got a half. We got a half x. So I don't like fractions. So now we're going to do it again, but we're going to isolate x.
Okay.
Okay. So do it for me. How do I get rid of things that are harassing x?
Minus 2.
No, it's being multiplied by 2, and that's the last thing we do. We have to get rid of anything that's being added or subtracted to it.
Y.
Huh? How many
Minus
y's?
4y.
Yeah, minus 4y on both sides, right?
Yeah.
Okay.
That's the
It disappears on the left.
Mhm.
How do we get rid of the last thing harassing it?
Divide 2.
Yeah, so we get this. Both of these things get divided by 2. This one has no fraction.
Yeah.
This one has a fraction. You always want to use the one that has no fraction. So this one's easier to use. You might say, well, why did we do this? It's because down here, I want to replace either the x or the y with something it's equivalent to.
Yeah.
Since I know x is equal to this up here, I can replace this x with it. Like this.
Yeah.
Okay, multiply this out for me.
So minus y
Mm-hmm.
minus 2y squared.
Yeah. Now, even though it says y, it doesn't really matter. It's still just a missing thing.
Yeah.
Okay, complete the square for me. There's no number being added here.
So what do you want me to do?
So right now, this is an area formula with just one unit. Doesn't matter that it says y.
Yeah.
I want you to complete the square the way we've always been completing the square. What is it harassing the y, the x squared or the y squared? So
Negative 2. So
we're
then
going to
you
factor that out, right?
substitute it out of the 900. Yeah.
What?
Substitute.
There's no substitute. What
-2.
do I do?
Oh, I mean factor out. Sorry.
Yeah, so what do I do? Just pretend it doesn't say y. Just pretend that says x. It doesn't matter that it says y, okay? It's just a number.
Yeah. Negative 450.
There you go. There's no number. Now what's your next step in factoring? In completing the square, rather. Completing the square.
Negative 225.
There you go. Now I can just do y minus 225. And here's the hard part. And we put a square. And the only problem is we have to subtract that square. So in this case, we have to use our calculator. It's 225 we can't do in our head. Sorry, yeah, it should be 225, not 255. So I'm going to be, let's clear that. So I'm going to be subtracting this number. Big
Yeah.
number.
Mm-hmm.
I'll just put a little lower. And keep in mind that that should say 225, not 255. Now, even though that number, there was no number outside, we still have to multiply it by -2 to get it outside the bracket because there's a -2 here.
Yeah.
Okay, so I'm going to take the number we came up with. It's a
Yeah.
negative number, and I'm going to multiply it by -2.
Mm-hmm.
And I get this number. There we go. And let's try that again. Get rid of this other crap here. So get y minus 225 squared plus 101,000 is equal to the max area, or the area. Sorry.
Yeah.
What's the vertex?
The vertex is part of 225 and 101,350.
What does the 101,250 represent, you think? What's the y over here in this case on the left side? I know there's a y in it. Just pretend that's just x. It doesn't matter. Y is always the thing on the left. So what does y represent in this case?
The area.
Yeah. So what does this number represent if this is the vertex?
The area.
The max area, because it's the
Yeah,
maximum.
the maximum area.
It's the maximum point of the vertex.
Okay.
What do you think this represents? Be careful here. All has to do with the letter we used here.
That's what the x value. So that's
Well, it's the x value in the formula, but what letter do we actually figure out from
y. That's y.
Right. So that's probably here, up here.
Yeah. Yeah.
So if that one here is 225, and this one's
Yeah.
225, and this one's 225, and this one's 225, how do I figure out x? It all goes back to perimeter here.
Mhm.
So what's my y that you figured out?
225.
Right. So it goes in here, right? 4 times 225. 4 times 225 is 900. So I get 2x plus 900 is equal to 1800. What do I do?
Yeah.
Trying to solve for x now.
Minus 900.
Yeah. I got 2x is equal to 900.
Divide by 2.
Yeah. 2. So x is equal to 450.
Yeah.
So what's
Okay.
my dimensions? My dimensions are 450
450 and
by 225.
Yes.
And if I add up all that, that's 900
Yeah.
plus 900. That's the 1800 in fence. And if I multiply them, I get
Mhm.
my max area.
Mhm.
And that's what he's concerned with. And why? Because
Yeah.
he wants to be able to hold as many things inside the fencing for the price of
Yeah.
that fencing.
Yeah. Okay.
These maximum questions, they happen all the time in engineering.
Mm-hmm. Okay.
All right. So you have to be able to do them, go practice them. They're always the same. These area formulas are always
Okay.
the same. You have to figure out one formula for perimeter, one formula for area. The finance questions are always the same. You have to figure out what's going up, what's going down. You have to understand what they represent. Sometimes it gets confusing because we use Y here. We didn't have to. I could have labeled the box Y on
Yeah.
the length and X on the short, and then our problems would be easier.
Yeah.
So all I had to do was label the X's on the short stems of this pen, and then it wouldn't have gotten confusing. But these areas are always done the same way. The revenue's always done the same way, and the Hercules and divers are always done the same way.
Yeah. Okay.
You have to practice them all because they're going to ask the same questions over and over and over again with different numbers.
It will. Yes.
Did he add other sheets for the test, or is this it?
Yeah. No. Tomorrow. sometimes. So
Okay, send the
I'm sure I'll
test
get
review.
more stuff.
Send
Yeah,
the
I
test
will.
review and I'll try to do some of them. But you should really take these questions and these ones and practice them. They're very common. It's the typical, they're asked every time.
3 times.
Okay.
And since he asked 4 revenue questions, I suspect your test is going to have a lot of revenue questions. Good?
Good. Yes, good.
And what's the one thing I want you to do that you're not doing?
Practice.
Yeah, thanks. Take care.
Okay. All right. Thank you. Bye.
Bye.
Enormous glow is made of love. Enormous glow is made of love. Enormous glow is made of.
On the bubble, this is what Mother Nature is? I dare say no. She's decided we're to receive a little bit more snow, and let's get right into it. As mentioned, yes, the highest concentration of snow in the northern part of our viewing area, and it continues to fall here right now. And this is a look at the temperature outside your door, -5. Hey, we threw in the wind chill just for fun. -11 is what it feels like in Parry Sound. Looks like it says where's your glasses case? -12 with the wind chill in Orillia and -11 with the wind chill in Newmarket. Give us one more, -7 in Toronto. This is the almanac for today, -1, -11, or make that -4, -11. And yes, it is chillier than normally it would be at this time of year, but 12 degrees, woo, 1996, a long way from 12, and -17.8 in 1891. Sun rises tomorrow, 7:36, sets at 4:40, 9 hours and 4 minutes of daylight. This is a look at the forecast radar, and there's the snow, and everybody gets some in varying amounts. Look at Trona, gets a pretty good blast too. There it is. Okay, there it goes. And southern tip of Georgian Bay, Lake Simcoe overnight, -5, -7, mainly cloudy skies, and yes, some